In this video, I will show how to make cooling unit compressor capacity calculator. Compressor is the core device of the cooling unit. The performance of the compressor represents the performance of the cooling unit. Technicians often need to check the cooling capacity of compressors under different operating conditions. Cooling capacity provided by most compressor manufacturers is curved, very inconvenient and time-consuming to look up. For example, here we want to check the cooling capacity at 7.6 degrees evaporating temperature, 50 degrees condensing temperature, and 60 Hz speed. From the intersection of the drawings, it can be seen that the approximate cooling capacity is 3,800 watt, and the deviation of visual inspection is relatively large. If the speed is 90 Hz, you have to check the 90 Hz curve. If there is another frequency, e.g. 81 Hz, and another condensation temperature, e.g. 51.3 degrees, which is not a point on the upper line of the curve, it is even more complicated. And is there a way to make this take a little more accurate? The answer is yes. The Getdata tool is used to get the numbers. Open the Getdata software. Open the curve image imported into the software. The curve needs to be saved as a JPG image and then imported. Anchor the minimum and maximum x-axis points on the image and enter the corresponding values. Anchor the minimum and maximum y-axis points and enter the corresponding values. Still with the example we just had, we have to check cooling capacity at 7.6 degrees evaporating temperature, 50 degrees condensing temperature, and 60 Hz speed. It can be seen that the approximate cooling capacity is 3,660 watt. In the same way, we can take points for different operating conditions and display the results obtained in numerical form. This is still not convenient enough. Is there a simpler way? The answer is yes, and that is to make a formula and enter the numbers directly into the table to arrive at the result. How do you do it? In fact, according to a formula equation of 15 coefficients, the coefficients are calculated by substituting the known variables and resultant data. And the 15 coefficients can be used to calculate the output parameters directly from the input condition parameters. In our formula here, Y represents the cooling capacity, F represents the frequency speed, TE represents the evaporating temperature, and TC represents the condensing temperature. A1 to A15 are coefficients that need to be solved for with known data. Next, use the Getdata tool to obtain the cooling capacity at different speeds, evaporating temperatures, and condensing temperatures. As many groups as possible, the more groups of data, the more accurate the calculation. These extracted data are then entered into an Excel spreadsheet in the order in which they were extracted. The data for this compressor have been given and I have filled them in this format. The upper part is for 90 Hz and the lower part is for 60 Hz. This data, for example, is taken from the Getdata tool. And the rest is similar. If we also need to calculate the power and current under different operating conditions, the method is the same as for calculating the cooling capacity. So here we will only present the calculation of the cooling capacity. Once we have organized the data collection, we move on to the next step. Using these data, we now proceed to solve for the coefficients A1 to A15. The coefficients you see here are the ones I have already calculated. Open this data analysis software. Maintain the default settings and delete these code elements. Then copy in the contents of the code for solving the pentadecimal equation. The contents of the corresponding 4 columns are then copied in. Click on Execute Calculate button to start solving. When the solution is complete, copy the 15 coefficients from the solution into an Excel spreadsheet. You can see that the coefficients are not the same as in the previous solution, and they may be different each time, but it doesn't matter. Here we can see that the calculation of the cooling capacity is a formula that relates the speed, the evaporating temperature, the condensing temperature and 15 coefficients. Let's try what the calculated values look like with different solution factors. The results are essentially indistinguishable. Now that we have done that, let's try the calculations for different operating conditions. Nothing seems out of the ordinary. This is the organized tabular format. And this part is the finished calculation table. This part is the description of the calculation process and coefficients. This part is the data list. This part is the initial data from compressor specification, sometimes show curves. That's how to make compressor capacity calculator.